Space is big. Really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. To understand just how big space is, we need to take a journey starting somewhere close by. This is our nearest star, Sol, our Sun. It is a white, main sequence G2 type star, one of about 100 million others like it, in a galaxy of over 200 billion stars, and it is the central body of our solar system. With every second that passes, an enormous amount of energy is released from the Sun's outer regions in the form of radiation, that includes light, and solar wind. Let us suppose that we could ride on a beam of light as it leaves the Sun's photosphere on its journey to space. Thus, we are now travelling at the maximum speed anything in our universe can achieve, some 4,500 times the speed of the fastest moving object ever made by humans. We'll ignore the effects of special relativity and just imagine all the planets in our solar system are in alignment at their average orbital distances. For the first few moments of our journey, no more than 10 seconds, we are still inside the Sun's corona, a kind of atmosphere for a star consisting of very hot plasma, in some regions over 1 million Kelvin. Here, the corona can be seen during a total solar eclipse, extending millions of kilometers into space. Once we get past it, we have a journey of about 3 minutes to the first planet, Mercury. At almost 3 times closer to the Sun than Earth, a Mercurian year lasts just under 3 Earth months, and because the planet rotates very slowly, its day side is extremely hot and its night side very cold. The cratered surface evokes images of a tremendously violent young solar system, a topic for a future episode. After our fleeting visit to Mercury, we continue on for a little under 3 minutes to see the planet Venus, or at least to see the top of its dense atmosphere. The surface of Venus can only be seen by sending landers, which don't live very long, or by using radar. Indeed, so thick are the clouds on Venus that at the surface, its temperature is actually higher than that of Mercury. But if you were to visit the surface, this would only be one of your problems. You'd be poisoned, you'd be fried, you'd be squashed flat. A decidedly unappealing place for a holiday, and yet long ago not so different from our next destination. 2 minutes and 20 seconds later, we arrive at the planet Earth, our home in space, humanity's harbour in the cosmic ocean. We have now travelled 8.3 light minutes, about 150 million kilometres. Next time you're out on a sunny day, remember that you are seeing the Sun as and where it was over 8 minutes ago, relative to the star itself. As we will see in a future episode, this delay over large distances fundamentally changes our concept of time and what the universe is really like right now. After another 4.5 minutes or so, we come to the red planet, last of the terrestrial planets, a cold and a dry world. Long ago, however, Mars held lots of surface water, rivers, lakes, and perhaps even small seas. This makes it an exciting place to search for traces of alien life that may have thrived there for some time before the planet dried up and lost most of its atmosphere. Mars will also be the first alien planet that humans set foot on, perhaps before the end of the 21st century. During our half-hour voyage to Jupiter, we passed through the asteroid belt, a collection of oddly shaped rocks left over from the formation of the solar system. The largest of these, Ceres, is a dwarf planet, 23 light minutes from the Sun. It accounts for 1/3 of the total mass of the entire belt. As we reach the realm of the gas giants, the distances between the planets continue to grow. We pass Jupiter and its 63 moons 20 minutes after Ceres, and then begin a 37-minute hop to Saturn, the ring world. Saturn's rings themselves are very thin, no more than 1 kilometre high, but the width of the brightest components is equivalent to the distance between the Earth and the Moon, about 385,000 kilometres. After Saturn, we now have an 80-minute journey to Uranus. This bluey-green planet also has a set of rings, as do all the gas giants, though certainly not as conspicuous as Saturn's. But the entire system is toppled on its side for unknown reasons. We are now nearly 20 times further from the Sun than the Earth, and it's cold out here. Past Uranus, it takes us a full hour and a half to reach its deep blue near twin, Neptune, about 50% further away from the Sun. Only one spacecraft has visited these lonely worlds, Voyager 2 in 1986 and 1989 respectively, sending back these incredible images. Now that we have passed all 8 main planets in our solar system, we enter the Kuiper Belt, realm of the trans-Neptunian objects, or TNOs. The most well-known of these is the dwarf planet Pluto, a 78-minute hop from Neptune. It's not alone, however. Hundreds of other dwarf planets, including Hyume and Makemake, also lurk in this distant space, each taking some hundreds of years to complete just one orbit of the Sun. Beyond the Kuiper Belt, we reach the scattered disk. The dwarf planet Eris orbits in this region, and it's slightly larger than Pluto. This disk of objects accompanies us almost all the way to the Sun's heliopause, the boundary to interstellar space. But even beyond this boundary, it is believed that the solar system continues in uncharted territory, with the Oort cloud, about 1 light-year from the Sun. This cloud of perhaps 1 trillion icy bodies, if it exists, is the source of all long-period comets. At 1 light-year, we may be inclined to feel we've travelled a long way. After all, 1 light-year is almost 10 trillion kilometres, but this is no more than a fleck of paint on a cosmic canvas. To reach our nearest neighbouring star systems, the binary Alpha Centauri and its companion red dwarf star Proxima Centauri, we would need to ride our beam of light for a further 3 years and 3 to 5 months. By today's conventional means, such a trip would take us over 40,000 years. But these are just the very nearest neighbours. The vast majority of all stars are orders of magnitude further away. We live in a spiral galaxy, a giant star city comprising over 200 billion other systems. The hazy glow of countless stars lights up a band of the night sky, once thought to be drops of milk spilled by the gods. We call it the Milky Way. From our starting point in the local spur between the Perseus and Sagittarius arms, it would take our beam of light some 25,000 years to reach the centre or the nearest edge of the galactic disk. We could travel out of the disk to a relatively nearby dwarf galaxy that is passing by the Milky Way, the Large Magellanic Cloud. However, it would take us about 160,000 years to get there. Our nearest large galaxy, Andromeda, is a real monster. It houses possibly about 1 trillion stars. Our beam of light takes 2.5 million years to reach it at this moment, but in several billion years, Andromeda will seem uncomfortably close as it collides with the Milky Way in a spectacular galactic merger. These 2 galaxies sit near the centre of the local group, a collection of about 30 galaxies and dwarf galaxies that spans 10 million light-years. This group is one of over 100 groups and clusters that make up the Virgo supercluster. To leave this massive bubble of galaxies would take our beam of light 55 million years. So far from home, we are now seeing the universe on the largest of scales. Huge voids spanning hundreds of millions of light-years separate superclusters of galaxies, many of which are arranged in massive cosmic structures, such as the Great Wall, a sheet of galaxies covering an area of 500 million by 200 million light-years. Moving deeper into the universe, we can see objects that appear to be as far as 13 billion light-years away. But due to the ongoing expansion of space, we now know that they lie roughly 3 times further from us than that. Our beam of light would never be able to reach the farthest objects, as they move away faster than we can chase them. Beyond this visible horizon of 46 billion light-years, we do not yet know how much further the universe extends. But it is unlikely that what we can see is all there is. As space expands at an ever faster rate, it may simply go on forever. In the future, cosmologists may yet be able to measure the total size of the universe, but for now, we cannot rule out the possibility that it stretches to infinity. A limitless black expanse with untold wonders, just waiting to be discovered.